Hi, I'm Margot Seltzer, and I'm delighted to be introducing you to the y86 architecture. In each of the videos that we'll use throughout the course, on the cover slide, I'm going to tell you any new reading that we expect you to do out of Bryant and O'Halloran. I'll try to summarize the topics that we're going to cover, and then the learning outcomes are supposed to tell you what I think you'll be able to do after watching this video. And the goal of having you watch these before class is that when you come into class, we can use that time really effectively to help you apply what you've learned to prepare you for the graded assignments in the course. So join me in this journey. You may have seen a picture like this before, saying this is what a computer looks like, but I like to call it the artist's rendition of a processor because it's greatly simplified. And although we're going to use this to describe the y86, in reality, processors today really look much more like this. They're way more complicated. And my hope is that by the end of the course, you'll understand what this diagram is really telling you. Without further ado, let me introduce our friend, the y86 processor. We're going to present it from the point of view of what's called the ISA, or instruction set architecture, which tells you what are the pieces of the hardware that are actually visible to someone who's programming in assembly language. Let's begin with the registers. Registers are high-speed memory, and they're typically used to do all the manipulation with data that you want to happen really fast. Registers are grouped together into something called the register file. And on the y86, we have exactly 15 of those registers. And we give special names to some of them. And in particular, we give those special names that match some of the register names that are used on the Intel x86 architecture. So things like RAX and RCX are names that you will see if you look at Intel assembly. And in particular, what you might notice is that register 4 is called the stack pointer. And that is going to be crucial throughout the rest of this course. After the registers, we have condition codes. These are bits of state in the processor that tell you things about the most recent ALU operation. Now, we'll get to ALU in the next slide deck, but for now, what this says is that the last time we used that piece of hardware that I'm not telling you about, it produced something that was equal to 0. That's the Z flag. Or it produced something that was less than 0. That's the S flag for sign flag. Or we did an arithmetic computation that was kind of too big to work on this processor, and we couldn't actually represent it, and that's going to set the OF, or overflow flag. The next piece of hardware state we have is called the status register, which says, like, how am I doing? So in normal operation, the status register will almost always say okay. When you halt the processor, it will say halt. And toward the end of the course, when we talk about things like addressing faults, that's when you might see a processor that enters something like states 3 or 4. The next piece of state we have is called the program counter, or PC. And this typically contains the address of the very next instruction that you're going to execute. Finally, we have main memory, or DRAM, or as the book calls it, DMEM. And this is where all our data is ultimately stored. In the y86, we store that data in little endian order. And if you don't know what that means, stay tuned. We'll have some exercises on it later, but it's going to be really important that you understand that as we start interpreting what the data in memory represents. Now let's talk about what instructions look like on this architecture. I'm going to introduce the instructions in different classes, and today we're going to only talk about the most basic ones. But all the instructions have a similar representation. And if you can see my cursor here, what you'll see is that the very first nibble, a nibble is 4 bits or half a byte, contains an opcode, okay? And immediately after that, the other half of that first byte is a function. The opcode basically says, what instruction are you using? And for some instructions, what we see is that they actually need additional information. So for example, there are a whole class of jump instructions, and sometimes those jump instructions require other conditions, like are you jumping when you're bigger or smaller or whatever. So as we look at the different classes, you'll find out which instructions need this function and which ones don't. After we have the opcode and function, all of which are captured in a single byte, we sometimes have registers, as in these two instructions, and sometimes we have big constant values that we're going to use. And so as we introduce classes, you'll see how these various pieces of the instruction are used. Let's begin with the simplest instructions. These have nothing other than an opcode. And the simplest instructions we have are opcode 0, which says halt the machine, moving us from status A-OK to status halt, or the no-op instruction, which is only marginally more interesting, but it does nothing, but it doesn't halt the processor. So ideally now you have an overview of the y86 processor, and when you go on to the next video, we'll learn about more instructions.